Hey YouTubers, thanks for joining me here with another video with random chemistry. In this video, we're going to continue to practice mole to molecules and molecules to moles conversions. We'll get started with this question right here. How many molecules are in 7.62 moles of neon? To solve this, we're going to use dimensional analysis and we're going to use Avogadro's number as a conversion factor. So start with what we're given, 7.62 moles of neon. And I'm going to use Avogadro's number, which tells us for every mole is 6.022 times 10 to the 23rd power. So if I have moles up top here, I want moles on bottom. So 1 mole of neon, for every 1 mole of neon, it contains 6.022 times 10 to the 23rd particles or molecules of neon. So moles cancel out, and I'm left with the molecules of neon. So now I just plug this into my calculator. 7.62 times 6.022 to the 10th power divided by 1. You don't have to put this part into your calculator, just do 7.62 times 6.022. And when you plug just that into your calculator, you're going to get 45.89, and then you carry over the times 10 to the 23rd. I don't know if your instructor will accept this answer because technically it's not in scientific notation. To put it in scientific notation, we would have to move the decimal point, so it would be 4.589 times 10 to the 24th. We moved the decimal point to the left, so that increased it by a power. So this is the correct answer in scientific notation. If you're not familiar with scientific notation, check out my video on it. Here's our next question. How many moles of magnesium oxide are there in 8.96 times 10 to the 25th molecules? So we're going to start this using dimensional analysis using what we're given. So 8.96 times 10 to the 25th. I'm going to put particles instead of molecules. So particles of magnesium oxide. And we're using Avogadro's number as a conversion factor. So if I have particles on top, I need particles on bottom, so that means I'm using Avogadro's number on bottom. 6.022 times 10 to the 23rd particles of magnesium oxide. And that's for every 1 mole of magnesium oxide. So particles of magnesium oxide cancel and particles cancel. Now you can see we're left with moles, which is what it's asking us. But what I really want to point out is that 10 to the 25th is not going to cancel with 10 to the 23rd. Last time we had the same powers, 10 to the 23rd, and they were able to cancel out, so we weren't worried about that. But this time we don't, so we can't simply do that. So there's 2 different ways that you can do this depending on how comfortable you are with scientific notation. If you're not very comfortable, go check out my video. So one way that I've seen people do is change the powers within the equation so that way that they are the same. So you could change this to 10 to the 25th by moving the decimals, or you can change this to 10 to the 23rd by moving the decimals. I typically don't like to do that because sometimes I get messed up or I move my decimal points the wrong way and I end up being wrong. So I'm going to show you a different technique. So the first thing you're going to do is plug in your coefficients into the calculator. You would do 8.96 divided by 6.022. When you put that into your calculator, you should get 1.488. And then we have our times 10. So when you're dividing exponents, you would just subtract the denominator from the numerator. So it would just be 25 minus 23, so it would be 2. So our answer is 1.488 times 10 to the 2nd power. So your instructor may want this in standard form, not in scientific form. So to do this, you would just move your decimal point 2 places. So it would be 148.8 is the answer. 148.8 moles of MgO. Here's our last question for this video. How many moles are there in 2.79 times 10 to the 21st particles of sodium chloride? Start with what we're given. 2.79 times 10 to the 21st particles of sodium chloride. And we'll use Avogadro's number as a conversion factor. So if I have particles of sodium chloride on top, I want it on bottom. So 6.022 times 10 to the 23rd particles of sodium chloride for every 1 mole of sodium chloride. So particles cancel, and I'm left with moles of sodium chloride. And now we plug this into our calculator. 2.79 times 1 divided by 6.022. And when you plug this into your calculator, you're going to get 0.4633. And then now we need to worry about our exponents because our exponents didn't cancel out. So it would be times 10, and it would be 21 minus 23. So that is a -2 moles per sodium chloride. So this is written in scientific notation. Your instructor is probably going to want it in standard form. So to do that, we just need to move our decimal point. So this is a negative exponent, which means our decimal point is going to move to the left 2 spaces. So 1, 2, which means our answer is 0.00463 moles of sodium chloride. And again, if you're not familiar with scientific notation, check out my video. Alright, YouTubers, thank you so much for joining me during this video with random chemistry. Please comment, like, subscribe. I really want to hear from you. If there's any material that you specifically want me to cover, if you have any questions, please leave me a comment. Thank you again for joining me, and we'll see you next time on Random Chemistry.